Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you are fine and enjoying with your own life. Students, in the last class we discussed some of the assignment problems that if we are facing a situation like if we want to assign the different jobs to the different machines or to the different persons, then how we can find out the optimal solution so that we can assign the different jobs to the different machines in such a manner that we can maximize the profit. So in the last lecture we especially discussed the situation of assignment problem in which we are interested to maximize our objectives, that is profit maximization. And you remember that I introduced you two steps what we can follow while we are interested in the maximization of profit. We can use two options. In first option, what we do, we can change the signs of the original payoff matrix, that is the original matrix in which we are provided with the profit margin, when we are going to assign the different jobs to the different machines. So what we can do, we can change the signs of all of these values, and thereafter all the steps remains almost same. Only the first step is different with respect to the process we adopted in case of minimization of cost. In second case, we can also use another option, that is we can find out the maximum number out of the given values, that is out of the original matrix. And what we can do, we can subtract each and every value of the matrix from this maximum number. So we can get another matrix, and thereafter again all the steps remain same, and again we can use the Hungarian method in order to find the solution of this assignment problem. And now you must remember all of the steps of that Hungarian method, that first of all what we do, we find out the minimum number out of each row, and then we subtract this minimum number from each respective row. This is the first step we usually follow. Then in the next step, what we do, we find out the minimum number out of the different columns. Then again we subtract this minimum identified number from each value of the respective column. So after these two steps we usually follow the step number 3. Now what we do in step number 3, we'll have to assign the different assignments, especially at the different zeros available in this matrix. And usually we start from the first row, and we will see that whether there is any single zero in a row. If there is a single zero in a row, we will assign that zero, and you know that how we can assign it in that matrix. We just make a square around that zero. Similarly, we will check on all the different rows, and initially if there are two zeros in a single row, what we can do, we can initially leave this particular row. Now after completing all of the rows, we will repeat the same process for the different columns. Again we will check out whether there is a single zero in a column, and accordingly we will assign that zero. And also we will have to cross down all the other zeros in the respective rows. The same is true when we are going to check the different rows. So if initially there are more than one zero in a column, we can initially leave this column. So we will continue this process until all the zeros are either being assigned or being crossed. So this is very important, that we will have to repeat this step number 3 again and again until all the zeros are either assigned or either they are being crossed. So after this step, maybe you may find the optimal solution after doing this particular step. But if you don't find the solution even after this step number 3, then we'll have to move to the next step. In next step, what we do, I have introduced you a ticking method, and I told you that in most of the books this method is not available, and hypothetically we draw the lines for eliminating the different zeros. But I especially introduced a special method for you people, so that there is no confusion and that how we should draw the lines in order to eliminate the different zeros. Now in this particular step, what we do, we will just tick the rows which are not unassigned. That is, we will tick the unassigned rows, and if these ticked rows have zeros, then we will tick the corresponding columns. And again, if these ticked columns have the assignment, we will take the corresponding rows. Now these are three sub-steps you will have to follow in this particular main step. After doing all that ticking, what you will do, you will draw the lines on the unticked rows and ticked columns. And again, the number of lines drawn will be equal to the number of assignments you have made for this particular table. So again, this is a check that whether you are doing in the right direction or not. So after this particular step, we follow a certain rule that we will find out the number out of this matrix through which no line is being passed. So what we will do, we will find out the minimum number out of these numbers, and we will subtract this particular number from all the numbers through which no line is passed. Then we will add this particular number from those points which are actually at the intersection of the different rows and columns and through which we have crossed through making those lines. So we will add this particular number at the point of intersection of the lines drawn, and the remaining numbers through which only a single line is being passed, those numbers will remain same. So this is a very important step. Students will have to carefully do this particular step, and again, if you remember all of these steps, then it will be easy for you to proceed with this particular problem. So after doing this, again we will try to have the optimal assignment, and again we'll have to repeat that step number 3, that is, we'll have to make the assignments on the particular rows and the columns, and again this step will be repeated until we have some optimal solution for our assignment problem. Another very important thing, class, up till now we have solved the different questions related to the minimization and as well as maximization, in which either we are interested in maximizing the profit by assigning the different jobs to the different machines, or we may be interested in minimization of cost by assigning the different jobs to the different machines or to the different persons. But you may have noted one important assumptions in all the questions we have just done, that is, the number of jobs in all the cases were equal to the number of machines. So that is a very important point. Up till now, in all the questions we have solved, we were facing the balanced assignment problem, that is, the number of jobs were equal to the number of machines or the number of persons to which these jobs are to be assigned. In our today's class, students, we will discuss the different cases. Now these cases are again related to the unbalanced assignment problems. Now what are these unbalanced assignment problems? We may have faced the situation in our real world as well, that there are the different jobs and there may be the more number of machines available, and we will have to assign these jobs to any of these machines, but the number of machines may be more than the number of jobs available. On the other way out, it's also true, sometimes we may have more jobs and we'll have to assign these jobs to the different machines. In that particular case, the number of machines will be less than the number of jobs. So this is a situation which usually refer the unbalanced assignment problem. So let's discuss these cases one by one, and what particular step we will have to follow in order to deal with this unbalanced assignment problems. Now the case 1, students, this is the case when the total number of machines exceeds total number of jobs. That is, the number of machines are more than the number of jobs you are being assigned. In this case, what we will do, we will introduce the required number of fictitious or dummy jobs at 0 cost. Now, this is an important class. If suppose there are 4 jobs available and there are 6 machines available, so the difference is 2. So what we will do, we will introduce 2 dummy jobs for this particular sort of problem. Dummy jobs or the fictitious jobs. Now again, you must remember we have followed this sort of step in transportation problems as well. When the demand is not equal to supply, and we either introduce the fictitious demand destination or the fictitious source of supply. The same is true here for the unbalanced assignment problems, and in this particular case we'll have to introduce the required number of fictitious or dummy jobs at 0 cost or at the cost stated in the problem to get the balanced assignment problem, and then use the assignment technique to obtain the optimal assignment. So what we will do, we will just introduce the required number of jobs with 0 cost. That is important. All these dummy jobs introduced in this particular step will have 0 cost, and again thereafter all the steps will remain same that are being adopted in case of minimization or maximization problems. So students, in this particular case you will have to just introduce one particular step, that is, you will have to introduce the required number of dummy jobs with 0 cost. The fictitious or dummy jobs assigned to the machines mean that the corresponding machine will not be assigned any job. So dummy jobs are being introduced just to make the unbalanced assignment problem a balanced assignment problem, and there will not be any difference at the end when we were going to find out the solution to this particular problem. So dummy jobs are just introduced to make this problem balanced. Again students, case 2 will be, this is the case when the total number of jobs exceeds the total number of machines. So in this particular case, what happens, the number of jobs will be greater than the number of machines available, and in this case we will have to introduce the required number of fictitious or dummy machines at 0 cost. So similarly, what we will have to do, we will have to introduce the required number of fictitious or dummy machines with 0 cost, and again we will use the same assignment technique to obtain the optimal assignment. All the other steps thereafter will remain same. The jobs which are assigned fictitious or dummy machines will be left over. At the end, what we will do, we will just ignore these dummy machines to which the different jobs may be assigned. So again we have introduced the dummy machines in this particular case just to make the unbalanced assignment problem a balanced one. At the end we will again get the optimal solution in the similar pattern as we have done for the balanced assignment problems. So these are the 2 different cases class, and again we will solve the different questions and illustrations related to each of this case, so that you can have a practice for this sort of unbalanced assignment problems. So let's first discuss a real-time example, that is when the machines exceeds jobs, that is when the number of machines available for the assignment of the different jobs are more than the number of jobs. So this is a particular problem we will solve today. There are 6 machines in this particular problem, that is M1, M2, M3, M4, M5 and M6. These are the 6 machines, but there are 4 jobs which are to be assigned to any of these machines, that is J1, J2, J3, J4. So there are 4 jobs in this particular problem, and again the cost being assigned a particular job to the particular machine is being provided in this table, and you can see that if we assign the job J1 to machine M1, we will have to bear the cost of $2 or 2 rupees, and again if we assign job 2 to machine 1, the cost will be $4, and again for this particular cell, if we assign job 4 to machine 6, the cost for this particular assignment will be $20. The same is true for all the other values, and what is being required in this particular problem, we'll have to identify that which job is to assign which machine to get the minimum cost. So again, students will have to find out the optimal assignment solution to this problem. But again, what is the difference in this problem? That this is the unbalanced assignment problem, because we have 4 jobs, that is J1, J2, J3, J4, but there are 6 machines, so number of machines are more than the number of jobs. So again, as a first step, what we will do, we will just introduce 2 dummy jobs at the different columns which have the 0 cost, and again this step is being done in order to make this problem balanced one. So in this given problem, there are only 4 jobs while 6 machines. In an ideal condition, there should be equal number of jobs, so we need to make them equal. For this purpose, we will introduce 2 fictitious or dummy jobs at the 0 cost. So this is the first step in order to solve this unbalanced problem. Now class, in this particular table, what we have done, we have introduced 2 different jobs, that is J5 and J6 for these columns. Now again, this step is particularly done to make our assignment problem balanced. And again, you can see that the cost for the assignment of these 2 jobs which we have just introduced to the different machines is 0. So the cost for assigning both of these jobs, J5, J6, to the different machines will be 0. So that is very important, that all of these assignments particularly related to the job 5 and job 6 will have the 0 cost. So students, again, now we'll have to follow the similar steps what we have followed in the minimization problem of assignments. That is what we will do. First of all, we'll have to find out the minimum number out of the each row, and then we will subtract this particular number from each and every value of the particular and respective rows. Now you can see that this is the first row, and this is the minimum value out of this first row, that is 0. Similarly, in the second row, the minimum value you can see is 0 again. In third row, the minimum value is 0. Fourth row, the minimum value is 0. Fifth row, the minimum value is again 0. In sixth row, again, the minimum value out of all the values of the different rows is 0. So this is the first step, and again, what we will do, we will subtract each and every value of this respective rows from this particular number. So again, you can see that as our minimum row value in each case is 0, so when we will subtract this minimum row value from each value of the respective row, again we will get the same rows, because in all the cases the minimum number is 0. So after this subtraction, we will again get the similar sort of matrix. So we have actually done that step number 1. Now in the step 2, that is usually referred as column operation, what we'll have to do, we'll have to identify the minimum number out of the different columns available, and then again we will subtract this value from each and every value of the respective column. Now you can see in the first column the minimum value is 2, so we have identified that 2 here. In second column, the minimum value is 4, so we have identified this 4 here. In third column, the minimum value is 3, that is 3. In fourth column, the minimum value is 4. In fifth column, the minimum value is 0. In sixth column, the minimum value is 0. Now after identifying this minimum number, what we will do, we will subtract all of these values from this number. So this is, in this step, we have subtract this minimum number from all the values of the particular columns. So finally, students, we get this sort of table. So up to this table, what we have done, we have applied the 2 steps, that is step number 1 and step number 2 of that Hungarian method. And now students, again we'll have to follow the next step, that is we'll have to make the assignment. And again we'll have to check down row wise first. So students, after the first two steps, that is row operation and column operation, we have this particular matrix. Now we'll have to go to the step number 3, that is we'll have to assign the numbers at the different rows and different columns. Now as a very first step, what we will do, we will start from the row number 1. As you can see from the row number 1 that there are more than 2 zeros in this particular row. So initially we can leave this particular row. Again in second row you can see there are more than 1 zero, so you can leave this particular row. In third row there are more than 1 zero, you can leave it. Fourth row, fifth row and sixth row, you can always leave all these rows because there is no single zero available in any of this row. Then start from the column. In first column you can see again there are 2 zeros, so you can always leave this column. In second column you can see there is a single zero available, so you can always assign this particular zero. If you assign this zero, you will have to cross down all the other zeros in the respective rows. So in third column you can see that there is a single zero available, and that has already been crossed. In fourth row again there is no zero spared. In fifth row there are more than 2 zeros, so you can just leave it. In sixth column again, in fifth column students, you can see that there are more than 2 zeros or more than 1 zero, so you can always leave it. So you can always leave this column. And again in sixth column there is more than 1 zero, so you can always leave initially this particular column. So we have completed one particular loop. So again you'll have to start from row number 1, because still there are many zeros which are not been assigned or crossed. So again start from the first row. You can see in first row there is no zero spared. In second row again there are 2 zeros. In third row again 2 zeros. Fourth row again there are 2 zeros available, so you can leave it. In fifth row you can see that again there are more than 1 zero, so you can leave it. In sixth row again there are more than 1 zero, so again you can leave this particular row. Now start from the column wise. You can see that in first column there is a single zero available. There is another zero, but that has already been crossed, so we can always assign this particular zero. And again you'll have to cross down all the other zeros in the respective rows. In second column you can see there is no zero available. In third column no zero available. In fourth column there is no zero available. Again in fifth column there are more than 2 zeros or more than 1 zero, so we can spare it. Again in sixth column there is more than 1 zero available, so we can always leave this column. Now this is the situation students we have faced in some of the previous problems, because now in every row and every column there is not a single zero available to which we can make the assignments, but still we have so many zeros. So what we can do, we can make the hypothetical assignment to the first available zero. So if you can see in the second row, this is the first available zero, so we can make the assignment, that is the hypothetical assignment to this zero. And again if you make this particular assignment, you will have to cross down all the other zeros in the related rows as well as the corresponding columns. In this way we can make this assignment. And again if you go to the row number 3, this zero can have the assignment, so just make this assignment, and now you can cross down all the other zeros in the corresponding columns. Now you can see that now we have 4 assignments, and which tells that still we are not getting the optimal solution. So now onward we'll have to go towards that ticking method, that is we'll have to tick down the unassigned rows. Now this is the unassigned row and this is the unassigned row. All the other rows are assigned, so we have ticked the unassigned rows. If these ticked rows has the zeros, then tick the corresponding columns. You can see that these rows have the zeros. These ticked columns have the zeros at this place and at this place, so we have ticked down the corresponding columns. If these ticked columns have the assignment, now this ticked column has the assignment at this particular place, so just tick it out. This ticked column has the assignment at this particular place, so just tick it out. So in this way we have completed this ticking, and after the ticking what you will have to do, you will have to draw the lines on the unticked rows and ticked columns. So unticked row, and the ticked columns. These are the ticked columns. Now after these lines, you'll have to find out the minimum number through which line is not being passed. And again, you can see a class, these are the minimum numbers, that is 1, 4, 6, 7, 2, 8, 8, 5, 1, 14, 12, 7, 1, 21, 12 and 15, through which no line is being passed. So what we have to do, we'll have to find the minimum number out of that, and you can see that the minimum number out of these values is 1. So we will subtract this 1 from all these values through which no line is being passed. So these values will become 1 minus 1 0, 4 minus 1 3, 6 minus 1 5, 7 minus 1 6. So it will become 0, 3, 5, 6. 0, 3, 5, 6. Now again class, this value will become 2885. If we minus 1 from each value, then it will become 1774. 1774. 1774. Similarly, this value will become 1 minus 1 0, 14 minus 1 13, 12 minus 1 11, 7 minus 1 6. So it will become 0, 13, 11, 6. 0, 13, 11 and 6. Now again, this value through which no line is being passed, it will become 0, 20, 11 and 14. 0, 20, 11 and 14. Now class, if we find out the points of intersection, you can see that this is the point of intersection. So at the points of intersection, what we do, we will add that minimum number 1 at these particular points. So these two cells will become 0 plus 1, 1. That is 1, 1. So these two cells will become 1 and 1. There is another point of intersection, that is this cell and this particular cell. So it will become 1, 1 again, 0 plus 1 and 0 plus 1. So these cells will also become 1, 1. All the other values through which only a single line is being passed, that will remain same. So the upper row, that will remain same, 0, 0, 0, 0. 0, 0, 0 and 0. Similarly, these values will also remain same, that is 0, 0, 0, 0, 0, 0 and 0, 0. Again class, this value will remain same, that is 0, 18, 17 and 13. 0, 18, 17 and 13. So class, now we have a new matrix, and now again we'll have to repeat the step number 3, that is, we'll have to make the assignments. If we start from the first row, you can see there are more than 1 0, so just leave it. In second row, more than 1 0, leave it. Third row, more than 1 0, leave it. Fourth row, more than 1 0, leave it. In fifth row, you can see there is a single 0, so you can make the assignment, and you'll have to cross down all the other zeros in the corresponding columns. Similarly, in the sixth row, you can see there is more than 1 0, so you can leave it. Again, column wise, in column 1 there is no 0 spared. In second column, there is a single 0. You can make the assignment, and again you will have to cross down all the other zeros in the respective rows. Third column, no 0 available. Fourth column, no 0 available. Fifth, more than 1 0, leave it. Sixth column, more than 1 0, so you can leave it. Now again class, you can see that again we have the situation that there is no row and column in which single 0 is available, but still we have many zeros which are either unassigned or not being crossed. So again we'll have to make the hypothetical assignment at this particular 0. So for this 0 we will make the hypothetical assignment, and again we'll have to cross the zeros in the related rows and columns. Then come to the next row, that is row number 3. You can make the assignment for this particular 0, and again you'll have to cross down all the other zeros in the relevant column. Now after this step, you can see that all the zeros are either being assigned or these are being crossed. So now again we'll have to see that this is not the optimal solution, because still we have 4 assignments, and we'll have to again do that particular ticking step. Again, tick the unassigned row. This is the unassigned row, so tick down the unassigned row. This row is also unassigned. Tick the unassigned row. If the ticked row has a 0, then tick the corresponding column. Now again, this ticked row has a 0 at this place, 0 at this place, 0 at this place, so we have ticked the corresponding column. If the ticked column has an assignment, now this ticked column has an assignment at this particular place, this ticked column has an assignment at this particular race, and this ticked row column has the assignment at this particular race, so tick the corresponding rows. So in this way we have completed the ticking. Again, we'll have to draw the lines. Draw the lines on the unticked row. This is the unticked row, and the ticked columns. This column is ticked one, this column is ticked one, and again this column is ticked one. So again, students will have to find out the minimum number out of those numbers through which line is not being passed. So you can see that out of these numbers, that is 3, 5, 6, 7, 7, 4, 13, 11, 6, 18, 17, 13, 20, 11 and 14, the minimum number is 3. So we will subtract 3 from all of these numbers, and again we will add this particular number at the points of intersection of the lines, and again that those numbers through which only a single line is being made, those numbers will remain same. So again we'll have to redraw this particular table. I am directly writing these particular values here. These values will become 3, 0, 0, 0, 4, 4, then again 0, 0, 2, 3, and 0, 0, then 1, 4, 4, 1, 0, 0, then 0, 10, 8, 3, 0, 0, then 0, 15, 14, 10, 1, 1, 0, 17, 8, 11, 0, 0. So class, after applying those particular rules, we will have this table. Now again we'll have to make the assignments. You can see in the first row there are more than 2 zeros, that is more than 1 0, so you will leave it. In second row there is more than 1 0, so you can leave it. In third row there is more than 1 0, leave it. Fourth row more than 1 0, leave it. In fifth row there is a single 0, so you can make the assignment, and you'll have to cross down all the other zeros in the corresponding column. Again in sixth row there is more than 1 0, so you can initially leave it. Then column wise, in column 1 there is no 0 spared. In column 2 you can see there is more than 1 0, so you can leave it. In column 3 there is a single 0, you can always assign it, and you can cross the other related zeros in corresponding rows. Then again fourth column there is no 0 spared, fifth column there is no 0 spared, sixth column there is no 0 spared. So again we can start this particular step. That is, again if we start from the first row, you can see that there is no 0 available. Second row no 0, third row more than 1 0, so leave it. Fourth row more than 1 0, leave it. Fifth row no 0, sixth row more than 1 0, leave it. First column you can see there is no 0 available. In second column we have a 0, so you can assign it, and again you'll have to cross down all the rows in relevant rows. So again we'll have to cross down all the zeros in the corresponding rows. Again third column no 0, fourth column no 0, fifth column more than 1 0, you can leave it. Sixth column more than 1 0, you can leave it. So after this particular step and loops, you can see that still there are different zeros available which are neither assigned or crossed. And again we'll have to use that hypothetical method, that is we'll have to assign this particular 0, and again we'll have to cross down this particular 0 in related row and the corresponding column zeros. Again fourth row you can assign this 0, and you can cross this one. Now class, again you can see that there are 5 assignments now available, and again this is not the optimal solution because we want to have the 6 assignments. So again we'll have to do that ticking step. Tick the unassigned row. This is unassigned row. Only one row is unassigned. If this ticked row has a 0, then tick the corresponding columns. If this ticked column has the assignment, then tick the corresponding rows. So this ticking is now completed. After this ticking, what we will do, we will draw the lines on the unticked rows. These are the unticked rows and the ticked columns. Again class, the number of line draws must be equal to the number of assignments. There were 5 assignments in this table and the number of lines drawn are also 5, so that is meant that we are going fine. So after this particular line drawing, we'll have to find out the minimum number out of these numbers through which no line is being passed. So you can see these numbers are 4, 4, 1, 10, 8, 3, 15, 14, 10, 17, 8, 11. We will find out the minimum value out of these. It will be 1. So we will subtract 1 from these numbers through which no line is passed. Then again, we will add this particular number 1 at the points of intersection, that is here, here, here and here, as well as this particular cells, and all the other values will remain same. So I'm just rewriting this table after applying that particular rule. So our next table will be like this, that is 4, 0, 0, 0, 5, 5, 1, 0, 2, 3, 1, 0, 2, 3, 1, 1, 1, 3, 3, 0, 0, 0, 0, 9, 7, 2, 0, 0, 0, 14, 13, 9, 1, 1 and 0, 16, 7, 10, 0, 0. So now class, you can see that this is the new table after applying that particular rule, and again we'll have to make the assignment to this table. You can see from the first row there is more than one 0, so you can leave it. In second row there is a single 0, so you can assign this particular 0 and you'll have to cross down all the other zeros in the corresponding columns. In third row there is more than one 0, so you can leave it. In fourth row there is more than one 0, so you can leave it. In fifth row there is a single 0, make the assignment and cross the corresponding zeros in respective columns. Then again in fifth row there is no 0 available. In sixth row there is more than one 0, so you can leave it. Now start column wise. In first column no 0 spared, second column no 0 spared, third column there is a single 0, so you can assign it, and again you can cross all the other zeros in the respective rows. In fourth column there is a single 0, you can assign it and cross down all the other rows in respective and cross down all the other zeros in the respective rows. And again in this particular column you can see there is a single 0. Again in this particular column you can see there is more than one 0, so you can leave it. In this column there is more than one 0, so you can leave it. Again class, you can see that again we have the situation that in every row and column there is not a single 0 available. So again you can make the hypothetical assignment at this particular point. That is, you will have to make the assignment at the this available 0. If you make the assignment for this 0, you will have to cross down this 0 and corresponding 0 in the respective column. Then again the only 0 left here, you can always assign it. Now after this particular steps you can see now we have 1, 2, 3, 4, 5 and 6 assignment. Now this is the situation that will give us the optimal solution, because now we have the 6 different assignments. Now you can see, to find out the minimum cost, you will have to refer back to the original table. Now this is the original table class. Now the cost of assignment of job J3 to M1, the cost of assignment of job J3 to machine M1 will be equal to this 3, which is static. Similarly, all the relevant costs for these particular assignments have been marked as static in this particular table. So this will be our final assignment plan, that will have to assign job 3 to machine 1. It will bear the cost of 3. If we refer back to the original matrix, again If we assign job 2 to machine 2, it will have the cost of 8. Job 4 to M3 cost is 10. Job 5 to M4 cost is 0. Job J1 to M5 cost is 2. Job J6 to M6 cost will be 0, and the total cost of this particular assignment plan will be equal to 23. Now again class, this is what we have the optimal solution now. Now again, in this particular assignment plan, you know that job J5 and J6 are actually the dummy jobs, and again these do not have any cost. So again we will just ignore these assignment, that is J5 to M4 and J6 to M6. We will just assign the rest of the jobs to the relevant machines as we have find out this in this optimal distribution. So again this is the final and optimal solution, and our total cost will be minimized as 23. So this is the case when we have less jobs and more machines. So again class, if we have more jobs than machines, that is number of jobs are more and number of machines are less, we'll have to follow the same rule, that is we can always add the dummy machines in order to have that balanced assignment problem. So in this particular problem you can see there are 6 jobs, that is J1, J2, J3, J4, J5, J6, and there are 4 machines, that is, and there are 4 machines, that is M1, M2, M3, M4. So we'll have to find out the minimum cost for a particular assignment plan. Again in this particular method what we will do, we will introduce the 2 dummy machines. Now suppose we have introduced the dummy machines M5 and M6, and again the assignment of the different jobs to these dummy machines will be 0. So we have marked that particular cost equal to 0 for these 2 machines. Now again class, we'll have to follow the same rules, that is in the first step we'll have to apply the row operation, that is we'll have to find out the minimum number out of each row, and we'll have to subtract that particular number from each and every value of the respective row. Again in first row you can see that the minimum number is 2, so you can subtract 2 from all of these values. In second row the minimum number is 3, third row 4, fourth row 3, fifth row the minimum number is 0, and sixth row the minimum number is 0. So if we subtract this particular minimum number out of each respective row, we will get this particular matrix. So this is the row operation, and now we'll have to apply the column operation, that is from each column we'll have to find out the minimum number, and then we'll have to subtract that minimum number from each value of the respective columns. Now class, in first column you can see the minimum number is 0, second column the minimum number is 0, in third, fourth, fifth and sixth column again in all the columns the minimum number is 0. So again we'll have to subtract this 0 from all of these respective columns, as the minimum number is 0, so it will not make any difference, and the our next table will be the same. So now after that row operation and column operation, what we will have to do, we'll have to apply the step number 3, that is we'll have to make the assignment to this particular table. Now class, again start from the first row. You can see that in first row there is more than 1 0, so you can leave it. In second row there is a single 0, so you can make the assignment for this particular 0, but you'll have to cross down all the other zeros in the corresponding columns. Similarly in third row there is no 0, in fourth row there is no 0, the 0 available is already being crossed. In fifth row there is no there is more than 1 0, so you leave it. In sixth row there is more than 1 0, so you can always leave it. Now start column wise. In first column there is no spared 0, in second column there is no there is more than 1 0, so you leave it. Third column more than 1 0, fourth, fifth and sixth column more than 1 0, so you can always leave it. So again after that particular loop, because we have still the different zeros, start from the first row again. In the first row you can see that this is a single 0, because the other 0 has already been crossed, so you can make the assignment for this 0, and you can cross the other zeros in the respective columns. In second row no 0 available, In third row, no 0 available. In fourth row, no 0 available. In fifth row again, there is more than 1 0. In sixth row, more than 1 0, column wise. In first column, no 0 available. Second column, more than 1 0, more than 1 0, more than 1 0, and more than 1 0. Now again, class, again we have this situation that there is not a single row or column through which we can make the assignment. So we will have to again make some hypothetical assignment from the first 0 available. So you can see that this is the first 0 available through which we can make the hypothetical assignment. So let's make the assignment to this particular 0. And again, all the zeros in the respective rows and columns should be crossed. Now again, if we see the row number 6, more than 1 0, you can leave it. Start column wise, no 0 available in first column, no 0 available in second column. There is a single 0 available in third column. Now you can assign it, and again all the respective zeros in the corresponding row zeros. Then again all the respective zeros in the corresponding rows should have been crossed. So after this particular method, you can see that we have 4 different assignments. So this table is not giving you the optimal solution. So as a next step, what you will do, you will apply it a ticking method. That is, tick the unassigned row. This row is assigned, assigned. This is unassigned row. This is unassigned row. There are 2 unassigned rows. Now if these assigned rows have the zeros, now these assigned row have the 0 at this particular place, then tick the corresponding column. And if the ticked column has the assignment, you can see that this is the assignment, you can tick the corresponding row. So after that ticking, what you have to do, you'll have to draw the lines on the unticked rows and the ticked columns. So these are the unticked rows, and this is the unticked column. This is also the unticked row. So class, again you can see that there are 4 lines drawn, and again we have the 4 particular assignments. So it means you are going right. Now again class, we'll have to find out the number from those numbers through which no line is being passed. These numbers are 5, 6, 9, 8, 7, 6, 15, 12 and 9. Now out of these numbers we'll have to find out the minimum number, and the minimum number in this particular case is 5. So we'll have to subtract 5 from all of these numbers. Then what we'll have to do, we'll have to add this 5 at the points of intersection. Now this is the point of intersection, this is the point of intersection, and this is the point of intersection. We'll add this 5 to all of these numbers, and again the rest of the numbers will remain same. So after applying this particular step, we will get the next table as, now I'm just writing down the next table after that particular step. Our new table will become 5, 2, 1, 3, 0, 1, 0, 0, 1, 4, 7, 4, 0, 3, 2, 1, 9, 7, 0, 10, 7, 4, 12, 7, 5 and 0, 0, 0, 0, 0, and again 5, 0, 0, 0, 0 and 0. Now students, this is our new table after applying that particular rule. And again we'll have to repeat the step number 3, that is we'll have to make the assignments starting from the first row. You can see that in first row there is a single 0 available, so you can make the assignment to this particular 0, and you'll have to cross down all the other zeros in the respective columns. In second row there is more than 1 0, so you can leave it. In third row there is a single 0, you can make the assignment to this particular 0, and you will have to cross down all the other respective columns. Then again in fourth row there is no 0 available. In fifth row you can see there is more than 1 0, so you can leave it. In sixth row there is more than 1 0, so you can always leave it. Now start column wise. In first column you can see there is no 0 spared. In second column more than 1 0, third column more than 1 0, fourth more than 1 0, fifth more than 1 0, and again in sixth column there is more than one zero available. So we'll have to again start from the first row. In first row again there is no zero available. In second row you can see that now there is a single zero available because the other zero is already being crossed. So we can make the assignment to this particular zero, and we'll have to cross down the respective zeros in the corresponding columns. Then again third row no zero, fourth row no zero available, fifth row more than one zero, leave it, sixth row more than one zero, leave it. Again column wise you can see in third column more than one zero, fourth column more than one zero, sixth column more than one zero. Again we have the similar sort of situation, that is we don't have a zero, that is we don't have a row or column in which there is a single zero available. So again we'll have to make the hypothetical assignment to any of the zero, or ideally to the first zero available. So you can see that this is the zero available. We can make the assignment, and we'll have to cross down the zeros in this particular row as well as in the corresponding column. So again you can see, if we see this row more than one zero, you can leave it. If we see column wise, you can see no zero, no zero, no zero. In this fourth column there is a single zero now available, so you can make this particular assignment at this particular point. So again you will have to cross down this particular zero. Now again class, you can see that now in this particular table we have 5 assignments, but still there are less assignments, and it will not give you the ideal solution. So again we'll have to apply that ticking method, that is tick the unassigned row. This is the only unassigned row. If the ticked row has a zero, then tick the corresponding column. If the ticked column has an assignment, then tick the corresponding row. So in this way we can make this ticking. After this ticking, again you'll have to draw the lines on the unticked rows and the ticked columns. This is also the unticked row, and the ticked column, there is only one ticked column. Again class, this is also the unticked row. So again class, you can see there are 5 lines drawn, and there were 5 assignments as well available. So it means we are going in the right direction, and we are doing nothing wrong. So after these lines class, again you'll have to find out the minimum number from those numbers through which no line is being passed. You can see that out of these numbers, that is 3, 2, 1, 9, 7, 10, 7, 4, 12, 7, no line is passed. You'll have to find out the minimum number out of that, and you can see the minimum number is 1. So what we will do, we will subtract this 1 from all of these numbers through which no line is passed. We will add this number 1 to the points of intersection of the lines, that is this one and this one and this one and this one. So we'll add this particular number at these particular locations, and the rest of the numbers will remain same, through which only the single line is being passed. So our new table will be like this after applying this particular rule, that is 6, 2, 1, 301, 101, 474, 021, 086, 096, 311, that is 11 and 6, then 6, 0, 0, 0, 0 and 0. Again this will become 6, 0, 0, 0, 0 and 0. Now class, again we have the table after that particular steps. Now again we'll have to make the assignments. Let's start from the first row. In first row there is a single zero, so you can assign it and cross the corresponding zeros in respective columns. In second row you can see there is a single zero, so you can assign it and cross the respective zeros in corresponding columns. In third row there is more than one zero, leave it. In fourth row there is a single zero, so you can always assign it, and you should cross the other zeros in the corresponding columns. In fifth row more than one zero, sixth row more than one zero, so leave it. Now start column wise. In first column there is no zero available now. In second column no zero available now. Third column more than one zero, you can leave it. Fourth column more than one zero, you can leave it. Fifth column no zero available. Sixth column more than one zero. So after that particular loop, you will have to again start from the first loop, because still we have the different zeros which are not either being assigned or not being crossed. In first row, no zero available. Second row, no zero available. Now in third row, you can see there is also a zero available, single zero. So you can assign it, and you can cross the other zeros in the corresponding column. Fourth row, no zero. Fifth row, more than one zero, leave it. Sixth row, more than one zero, leave it. Now again, column wise, you can see in third column more than one zero, sixth column more than one zero. So again, this is the situation that we'll have to make the hypothetical assignment. So if we make the hypothetical assignment for this particular zero and cross the corresponding zero in the column and in the related row, and again this particular zero is left, so we can always make the assignment for this particular zero. Now students, you can see from this table that now we have these 6 assignments. So it means that this table will give us the optimal solution. And what is the solution? That is, we'll have to assign job 5 to machine 1, job 2 to machine 2, job 4 to machine 3, job 1 to machine 4, job 3 to machine 5, and job 6 to machine 6, which is according to the relevant assignments, or by that scared zeros. Now again, in order to find out the cost, we'll have to refer back to the original table, and you can see that the cost from job 5 to M1 will be 2. That is the cost. Again, the cost for assigning job 2 to machine 2 is 8. Cost for assigning job 4 to machine 3 is 10. Cost for assigning job 1 to machine 4 is 3. Cost for assigning job 3 to machine M5 is 0. Cost for assigning job 6 to machine 6 is 0. So if we add up these costs, you can see that for this particular assignment plan, we will have the total cost of 23. So this is the minimum assignment cost. And again, students, you remember that M5 and M6 were our dummy machines. So we will just ignore these dummy machines or dummy jobs whenever these are being applied, just for balancing the assignment problem. So we will just ignore these dummy machines or dummy jobs, and the rest of the jobs may be applied to the rest of the machines. So in this way, we can get the optimal distribution for the particular assignment problem. So students, in our today's lecture, we discussed about the unbalanced assignment problems, that whether when the number of jobs are greater than the number of machines, or when the number of machines are greater than the number of jobs, in that particular case we can always apply the required number of dummy jobs or dummy machines, and the rest of the rules or the steps will remain same. So again, after those Hungarian method, after applying the Hungarian method steps, we can achieve the optimal assignment solution to our problems. So this is all for our today's lecture, students. I hope you will make the practice for the similar questions from your textbooks. Okay students, good luck, stay blessed. Khuda Hafiz.